Hey everyone, welcome to Tutoring. I hope you're having a great day. Today we are doing question 11 from your extended response chapter in chapter 2. Right, so obviously extended response questions are quite hard, but that's why we're going through it in this tutorial video. Hopefully this video helps you solve your issues with chapter review and makes you finish the chapter. Let's get into the question. Question 11. AOC is a triangle, the median CF and OE intersect at X. Right, so pretty much everything is in this diagram right there. Let's vector A equals OA, so we might as well label it. OA is vector A, so I'll put an arrow because the arrow is actually crucial, because if you put the arrow the other way, then you'll get a negative A instead, okay? And then OC is vector C. I'll put an arrow again. That is vector C, so O to C. Part A, so we'll do it right here. Find vector CF and vector OE in terms of A and C. So let's look at CF first of all. Vector CF, so from this point right here, C, all the way to F, right there. So how would you go from C to F without going from C to F? With vectors, you know you can take detours using other vectors that we know. In this case, if you want to find vector CF, you can go from C to O, C to O, plus, so C to O, and then plus O to F. So OA is 2 times of OF, really. So OF is essentially half of OA. This is because F is the midpoint of OA. So half of OA. Right. We know that OC is C, so CO would be negative C. And we know that OA is A, and therefore half of OA is just half A. Alright, so we got what CF is. Negative C plus half A. Let's find the next part, which is OE. Okay. How would we solve for OE? So to go from O to E, you can take 2 detours, different detours, O to A to E, or O to C, C to E. We'll take O to A to E for now, and that would be OA plus AE. That's it. We know that OA is just vector A, and we know that AE, if you want to go from A to E, right here, that is half of AC, half of AC. And we do know, we don't know what AC is, but we can find that out. So there is no vector B or D for AC, but you can make AC from OA and OC. And that is you go from A to O, so that's negative A right there. And then O to C, so that's it, plus C. And that's how you get vector AC. So going another detour, okay? And just add them up. A minus half A is just half A. And then plus half C, and that is it. So that's vector OE. So that solves part A. Hopefully it shouldn't be too much of a problem. If you do need help with vectors, check out my other vector videos so that you can improve on your skills. But let's move on. Part B. If OE is perpendicular to AC, so OE perpendicular to AC, this part right here, prove that triangle OAC, so the big triangle, is an isosceles, right? So we'll use to solve for this. If you want to prove that a triangle is isosceles, you need to prove that 2 sides are the same, and of course the other side isn't the same. In this case, just from the looks of it, you can maybe look at comparing OA so that it's equals to OC. It looks pretty obvious. It looks more obvious than OA and AC, but we can't just assume. Let's just do the maths. So we know that OE is perpendicular to AC. What that means is if you were to dot product these 2 vectors, so OE and AC, you should get 0. We know that for sure. But we can use that to help us find or to prove that this triangle is isosceles. So let's get into it first. What is vector OE? Vector OE we have already found. It is half A plus half C, right? So from this part right here, that is OE. And if we dot product that with AC, we know AC from our previous part as well is negative A plus C. So I'll just write that down. Negative A plus vector C. We let it equal to 0. Right, and then we expand our vectors. Just remember, this is not I, J, or K. So when you're expanding or when you're dot producting vectors, you just multiply them using FOIL, okay? So A with A with C, C with A, C with C. Not just A with A and not just C with C, okay? Right, so let's expand this. We get negative half A dot vector A, so the first part, and then we get plus half A dot C, and then negative half A dot C right here, and then the last part that will give us half C dot C, okay, and that is equals to 0. Right, move it over to the side a little bit. We know that these two terms cancel out because they're the same term and there's a negative in front of one of them. And of course, we have half of vector C dot C. So another way of writing that, hopefully by this point you should be familiar with how vectors work. You can write that as the magnitude square, and we can shift the negative half A times A over to the other side, and you get half A magnitude square, which therefore makes the magnitude of vector C equals to the magnitude of vector A. And that's pretty much it. Magnitude of vector C, this vector OC right there, is the same as the magnitude of vector A, so OA. These two sides are the same, and it's pretty clear that you can't have AC the same because AC is a combination of these two vectors. So therefore, triangle OAC is isosceles. And that's pretty much it, guys. If you want to write a description where AC is not the same length, you can do that too. But for now, I'm pretty sure you know what is happening, okay? So that's pretty much it for part BI. So if we're to write I over here, let's do B double I. So I'll put B double I right there. Sorry about the mix-up for the left-hand side and right-hand side. But double I, let's go into it. Double I, what does it say? If furthermore CF, C to F, right, so this red vector right there, is perpendicular to OA. So it's saying CF is perpendicular to OA, okay? Find the magnitude of angle AOC, and hence prove that triangle AOC is an equilateral triangle. Okay, so it's once again stating that another vector is perpendicular to another vector. And then we need to find this time the magnitude of angle AOC. So essentially, this angle right there, okay? So we need to find the magnitude of that. And then afterwards, we need to prove it's equilateral. But before we do that, let's get the magnitude of this angle AOC first. How would you do that? Well, if you want to find the angle of something for a vector, you use this formula, cos, and in this case, angle AOC. You can write that as theta if you prefer, equals to, well, you look at the vectors surrounding the angle. So that is OA, we'll call that, we know OA is A, and OC, so dot C, okay? So the formula is the two vectors divided by its magnitude, right? A dot C, right there. Now, the problem is, what does A dot C mean? And what does magnitude of A dot C mean? We can't do anything from that point on, right? There's nothing to go. But there is an information here that says if further CF is perpendicular to OA, we can use that to help us out. Like we did in part BI, we can say, yes, vector CF dot vector OA, if you were to dot product them, they should equal to 0 because they are perpendicular. And what do we know about CF? We know that CF from this first part A is negative C plus half A. So we'll write that down. Negative C plus half A. And what do we know about vector OA? Well, that's just vector A right here. Okay, so dot vector A equals to 0. Negative C dot A is negative AC. And then half A dot A is just plus half vector A dot vector A, and it's equals to 0. And we know that A dot vector A gives us the magnitude, okay? Magnitude, and we can bring AC to the other side, which in this case gives us A dot vector C. And as you can already see, A dot vector C is up here in the numerator. So we're getting very close. Now, what is A, magnitude of A dot magnitude of C? We know from part I that magnitude of C is equals to magnitude of A because the triangle is isosceles. So therefore, so this is very crucial. Therefore, cos angle AOC, so we'll have it as still vector A and C, we're going to sub that in soon, divided by magnitude of A times magnitude of C. Magnitude of A and magnitude of C are the same, so you can write it as magnitude of A times magnitude of A, which is the same as magnitude A squared. Okay, now you can probably see it right here, but a dot c is half a square. So magnitude a square, and there's a half in the front. And of course, that is just AC. We divide that by magnitude of a square, and voila, this cancels out, and you end up with cos angle, so theta, equals to half. And if you've done enough trig, you should know that cos inverse of a half, so angle AOC, cos inverse of a half, that is equals to 60 degrees, right? And that's pretty much it for this part. So finding the magnitude of angle AOC, it happens to be 60 degrees. Of course, we haven't finished it yet. We also need to prove that triangle AOC, this and big triangle right here, AOC, is equilateral, meaning all sides are the same, or all three angles are 60 degrees. We know that this blue angle right here, the one we just found, is 60 degrees. We also know that OA is and OC are the same length, so because they are an isosceles from the first part I, but an isosceles with one of its angle, with this angle right here, the top being 60 degrees, means that these two angles also have to be 60 degrees because they're isosceles. Because 180 minus 60 is 120 left over, divided by 2 gives us 60, 60. If the three angles on your triangle are 60, 60, 60, that leaves you with an equilateral triangle, right? And in this case, if you want to write that down, you can just write it here quickly. So just down here. Therefore, triangle AOC is an equilateral. And I'll just make a shortcut here, triangle equilateral sign. And that's pretty much it for part A and part B. So hopefully that helps you solve that issue. Let's move on to part C next.